Hello everyone, welcome back to Advent of Code 2025. I continue my little catch-up attempts here. I don't think I will be done before... I'm still releasing these one per day, so they're coming out like a week late. But I'm catching up a little bit, but I don't think I'm going to catch up the whole week. I'm not going to do like 3 a day for the next 2 days. So we're doing day 6 today. Day 6, Trash Compactor. After helping the elves in the kitchen, you were taking a break and helping them reenact a movie scene when you over-enthusiastically jumped into the garbage chute. What movie scene? Who jumps into garbage chutes in a movie? I immediately was thinking about, like, the famous I Love Lucy conveyor belt scene, but that's a TV show and not a garbage chute. There's, like, some Final Destination stuff where someone gets crushed in a trash compactor or in a truck? I don't know. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the door has been magnetically sealed. As you try to find your way out, you are approached by a family of cephalopods. Oh, what is it? What is a cephalopod? Is that... Cephalopod is like head, foot, right? Are those like octopuses? I gotta look up the word cephalopod. Back in a sec. I mean, I don't know. I'm not even pausing the video. Cephalopod. Marine mollusks, including squids, cuttlefishes, and octopuses. Okay, good. Yes, head, feet. Good. They have brains in their feet. They're pretty sure they can get the door open, but it'll take some time. While you wait, they're curious if you can help the youngest cephalopod with her math homework. Cephalopod math doesn't look that different from normal math. The math worksheet consists of a list of problems. Each problem has a group of numbers that need to be either added or multiplied together. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, each problem's numbers are arranged vertically. At the bottom of the problem is the symbol for the operation that needs to be performed. Problems are separated by a full column of only spaces. The left and right alignment of numbers within each problem can be ignored. Okay, so I think this just means they're separated, like, there will be at least one space in between this number and this number when they're in different columns. And so you don't have to actually do anything to understand them, like, where the problem starts or stops vertically. It's just there'll be a space in between the... Okay, fine. This worksheet contains 4 problems. Yeah. To check their work, cephalopod students are given a grand total of adding together all of the answers to the individual questions. Of course, the actual worksheet is much wider. You'll need to make sure to unroll it completely so you can read the problems clearly. Okay. Well, this seems pretty simple. And I think we're just looking at like a transpose sort of operation in a way. Right? We have a list of lists that we're going to read in horizontally, but we actually want to view them vertically. Seems straightforward enough. Let's go check out my input, make sure there's no big surprises. Goodness, there are a lot of numbers here, and there's the same number of operations of numbers in every problem, right? We don't ever have like 3 numbers in one column and 5 numbers in another column. All right, cool. Well, does each... Yeah, each row of numbers doesn't start with a space. So we'll know by just looking at the very first column whether we're parsing a number row or an operation row. Okay. So let's do the parsing. Well, I don't want to do the parsing until I've defined a couple types, I guess. Data problem is a problem containing a list of operand and one operator and we'll put them in this order. Where type operand is just an int and data operator is just plus or times. Fair enough. So the input should also be an actual data type this time. Data input should just be... Now, here's the thing. I don't want my input to be a list of problem, because we're going to lose some fidelity in a way. Well, maybe not. Well, I'm just thinking part 2 might be, oh, you've misunderstood the worksheet. You didn't unroll it all the way like we told you to. And actually, things are associated with each other in a different way. Right? And so I don't want to commit to, like, part 2 receiving the entire, like, having been transposed, right? I kind of want the input to be a list of numbers followed by a list of operator, and then we'll reassemble that into a list of problems as part of part 1. So I think an input is an input containing a list of operand and then also a list of operator. So in some ways, it's just a list of problem, but not really. Now, okay, this I don't think is a good idea, but I had this thought that I would like to express here. Which is that, look, there's some similarity here between problem and input, right? How do we capture this? We could say that an input is a list of problem, which is kind of the, like, that's currently, if I were to just assume part 1 is the only part, I think that would be a good way to view an input, right? But if I want to preserve the kind of column major axis of the actual input text, or no, row major view of the input text, rather than the column major view that they're telling us to parse things into, I would be breaking things if I said it's a list of problem. What you could do instead is say data problem of f. Problem is now takes a type parameter. It has an f list of operand and an f operator. And then we could say type input, I'll call this problem f or whatever. Type problem is f identity. It's just like a problem containing a list of operand and an operator, where the identity type just maps a type to itself. But input could then be a problem. Oops, what am I doing? A problem f of identity. A problem f of list. And so what that would mean is we would have a problem of list of operand and a list of operator, which is actually the input format we're given. I don't think this is like the smartest thing anybody's ever done or anything. But it is kind of interesting to reflect on that similarity, I guess. And you could maybe write functions that were generic in some way on the type of f. Like that could do something if f were any monad, maybe? Or any applicative? Would that make any sense? Because identity and list are both applicative, right? I mean, I guess if you use zip list, if you had a zip list of list of operand and a zip list of operator, you could zip them together, right? Like this? And then you could use an applicative combine. So like, okay, what if you said solve, provided that f is an applicative, could take a problem f of f and produce an f of int? This is okay. So could I write this function? Is this real? I don't know. I think so though, right? Because if you said solve of f of args and ops, let's say, is just like solve prime, I don't know, go of args and ops, where go. So now we'd be given go must, oh, whoops, args and ops, there we go. Go of go arg op, I think, is just a function that like is fold L strict of apply op. Well, but the problem is fold L1 strict, I guess. Arg? And we just need an apply function. Where data apply, what is data? Apply of plus is plus, apply times is times? Does this compile at all? I need to import identity in zip list. You think identity is in control applicative? I don't. Maybe. No. All right, where is it? Data functor. Data functor identity. Huh. Okay. Is it possible that it's just re-exported in data functor? I'm guessing no. Or Google would have told me. Okay, so now I can't have show because I don't know why exactly. Whatever, that's fine. Yeah, or. Alright, fine. Get rid of all this shit. Works for any. Okay, type problem. Incorrect indentation. Oh, the deriving clause should go, yeah. Oh, this should be problem F. Fold L1, okay. Is there not a fold L1 strict? It is, but you have to import it from data list, apparently. And then it's just upset that my input type is wrong. Yeah, there's no type. Why did I put applicative in the imports list up there? What was coming out of my head? I don't know what that's all about. Okay, so this is actually. Well, I guess I should really say operator to for all a num a. Do I have to add some extension to allow me to write this type? I do not. Okay. So that's interesting, isn't it? That now I have actually, by parameterizing the problem type in an interesting way, I've written a single function that can solve either one problem or a set of problems, depending on the type of argument you pass it. That's kind of cool. Let's use that. Why not? Well, okay, let's leave this commented out in case I find that, because I haven't actually tried running this on anything, right? But so how would I test this? I could, in GHCI, say solve of, takes a problem F of zip list so let's have 2 plus 2 is 4. 2, 2, and then another problem 5 times 10. 5 times 2. 2 times 5 is 10. So that's the zip list containing the operands. Oh, but this isn't how that's supposed to work. Is it? Oh, man. This should be... Well, I guess it sort of works because I've used 2 in so many places. So this actually is right, but I want to make it more. So let's say, okay, let's just make sure I use different numbers for every spot, right? So I think this represents the first row is 1 and 2, and the second row is 3 and 4. So we should be getting, I then also say zip list of plus times. I think this should be 1 plus 3, which is 4, and 2 times 4, which is 8. So I should get back a zip list of 4, 8. Oh, did I not import the zip list? I assume that it's called zip list, the constructor. It's a new type. Its constructor is indeed zip list. Okay. I guess it doesn't matter. I can just... okay. Yeah. No. I thought by using a zip list... So this has added 1 and 2 and multiplied 3 and 4, which means it's expecting things to already be in column major order, where I thought it would work in row major order. And I mean, we could do something cool if we just used ordinary lists. We could solve all the, like, different ways you could combine the numbers with operations. We get 1 plus 2 is 3, and 1 times 2 is 2, and 3 plus 4 is 7, and 3 times 4 is 12. This is not interesting. I mean, it's not useful. It is interesting, I guess. It's cool that it works with any applicative. So maybe I'm looking for a kind of traverse. Obviously, this is not the easiest way to solve this problem. I know that, you know that. But it's interesting, right? I think so. Because really, I guess, okay, I have this function here that solves things assuming they're already in column major order. So what I need then is a function that turns this zip list inside out in a way, right? And makes it into 1, 3. The type of transpose. I guess it just works with lists, huh? So, yeah, I mean, there's... So what if I sequence A this? Does that just, like, do what I want? No. That's not what I wanted. I got 4 lists out. Yeah. But, okay, so... a zip list with 2 elements. What does that mean exactly? It's been a while since I've worked with zip lists. So it is just the same as a list with 2 elements, of course, because it's just a new type around that. With the property that if you use an applicative operation combining that list with another zip list, it'll do so kind of pairwise instead of the Cartesian product. So maybe the point is that I should have actually Like, this outer zip list, I don't have anything else zip listy I actually want to combine it with, right? What I actually have is these inner things I want to combine with each other in a zippy way. So, alright, what if I actually made all of these zip lists as well? That is what I wanted. And I assume if I said 1, 2, 3, or no, I guess let's add another thing here. One, 3, 5, 2, 4, 6. So this is kind of transposing, right? It is just implementing transpose using the zip list machinery instead of using transpose. But, I mean, I think what that means is maybe I could still write this solve function if where does the f belong in my problem f, and where does zip list belong? It's sort of hard to tell from just the type itself, because obviously on the right you need an f so that there's a list of operators. And on the left, if I just think of f as being either identity or zip list, and then I add another layer of zip listing, like there's no real difference between f of zip list of operand and zip list of f of operand. But I guess having it at the outer level, having f at the outer level means that these two types, you can't see my mouse cursor unless I highlight something. These two types are the same outer type, so I can use applicative on them. So I guess maybe, what if I did this? So an f of zip list of operand and an f of operator. Now, does fold L1 still work? Yeah, expect specifically lists. Come on, there's got to be a version in foldable, right? There's just fold L1, huh? Okay, fine. I'll just use fold L1. I won't say it's strict, and it's just gonna have to be all right. I don't think I need that because it's in foldable, right? Yeah. So what if I then say, go back to this solve thing here? This was a silly solve. Bringing back the zip list one. Yeah, and now I have... No. What? What is this? I still have 1 plus 3. Oh, man. Oh, because I haven't done the sequence A. So I guess if I said sequence A of this... Yeah, now I get 1 plus 3 is 4. 2 times 4 is 8. So that's what I wanted. Do I want that to be part of solve, or should solve assume that it gets things in already row major order? I don't really know. Actually, no, this does have to be an actual list, not a zip list. Sorry, it has to be a zip list, not a normal list. Because I don't want, when I combine the list of operands with the list of operators, I want that done pairwise. And that's why this outer level has to be a zip list. And this inner level is a zip list just so I can do transpose, which is kind of stupid, but okay. I think this is like, I don't know. I think this is obviously a bad way to write this program, but it's interesting. And that's what Advent of Code is. One of the things Advent of Code is for is playing with ideas. So we could write the parser for this to produce a zip list of operand, I guess. The funny thing is I'm never going to actually use this problem type. Oh well. Import text regex applicative. And what do I need? Just symbols, some. I could, I don't want to import set by from that parser combinators library again. I guess I'll just define it myself. Okay, so I need the match operator. I need... Do I need some? Yeah. I need symbol for matching spaces and new lines and the various operators. That might be it. And then decimal for parsing ints. So let's down here by prepare. Oh, I can make it part of where sep where p sep by sep is first a P. Well, okay, I guess it's a fmap cons of P and... Oh, I actually do end up needing many, not just some here. And then apply that to many of ignore sep and then parse P again, right? Yeah, that looks right. Yeah, it has warnings about unused stuff, but sep by parses, or compiles even. Okay. So the input is a problem of... No, it's a problem F. Problem F of zip list problem of, oops, here we go. Well, I guess we do need a zip list, actually. Zip list of some zip lists of it's too complicated. All these stupid zip lists. Maybe I can just actually call coerce at some point. Forget all the zip lists, just return lists. It'll be simpler, and then yeah, that seems like a reasonable idea. Data coerce. Because zip list is it only really exists at the type level. You don't. It's the same runtime representation, and coerce converts between equivalent runtime representations for free. So as long as what I'm writing here has the right type, and it can infer the right type for input, coerce should be okay. I'm not sure. Problem F of, there are going to be several rows of problems. So we have sum of row. Row is pretty simple. I think it is args sep by some sim space followed by and ignoring a new line. Okay, and after the rows, we have a single ops ops is an op. I mean, it's basically the same thing, right? Oh, that's interesting, isn't it? I can make this a function. Row of P is a row of args and then a row of op, right? Where op is sim plus, oops, it's either plus associated with a plus, or it's times associated with a times. And an arg is just decimal, I think. So this surely won't compile, will it? Okay, I have to import or, which should be in here, surely. It's also in control applicative, I assume. Haven't imported from maybe. Only one error left. That's not bad. But the bad news is it's just it's something that I hoped would be handled by coerce. Oh, the issue is I'm calling problem F mapped over something. So it has to be suitable for problem F before I call coerce. Here. It usually does not work to do that, but let's see what happens. Yeah, it's saying your coerce is preventing you from telling what type you wanted. I don't even think it makes sense to have. All right. Maybe I can just say coerce this and coerce this. Probably not. No. So the issue is that some row of arg. Okay, I have one more idea before I start actually doing types myself, I think. What if we fmap the coerce in here? Saying parse a row, giving you a list, but then coerce it into a zip list. Okay, that actually looked promising, I think. No. You couldn't Match representation of something with operand for some reason. Yeah, but why not? I mean, at this point, we can probably just... like, we can write in the zip list things ourselves, right? Zip list of this. And then this coerce is also the zip list. And so is this one, right? I was hoping I could get something for free. Oh, and this one actually is free because row already has. Okay. Well, I guess I'll take it. Actually, our input type is not showable. Is that true? It is because, well, why can't, okay. Why can't I derive show? Do I need like show 1 or something? What's the deal with show 1? It's for things that have type arguments, like unary type constructors. Can I derive this? I think so, but I don't. Okay, I'm just going to put show 1 and see what happens. Haskell derive show 1. Is this a thing you can do? It's a higher kind of type. Yeah, I don't know if you can even... You can use generically 1 to derive these, I guess. Maybe? Something is sort of claiming. So the problem is I can't print these things to confirm that I've even parsed them correctly because... I mean, I can write it myself, I think. But not very well. It's a bit of a boondoggle, I guess. Well, okay. So I guess what we can do is say... First of all, we can prepare a read file input.txt. And does this throw? I mean, it's hard to tell. Let problem f ops are args ops equal this in args ops. So we've unwrapped it. I would have thought. What's wrong with this? I have an input, which is a problem f of zip list. I'm matching that. You expected an IO of input. Oh, the problem is I'm using let in. Okay, but okay. I need parentheses there. Prepare. Okay. I guess I should be doing it like this. Let problem f args ops equal prepare s in args ops. What is wrong with you, man? Read file input.txt. Oh, I guess, again, I should be f-mapping, shouldn't I? Error, no parse. All right, finally, I have proven that there's something wrong. Good. I have failed to parse. Okay. So instead of read file input.txt, let's just write like pure 1, 2 plus. So that works. And if I then said like 5, 6 times, that works too. Is there an extra new line that I didn't account for, maybe? I don't think so. No. Did I not handle that there are multiple spaces? Some spaces. There's one new line at the end here. That's what I... Oh, there's extra spaces at the end as well. Sometimes. Because the operators are shorter than the numbers. I see. I did not address that. Really what I want is like sep end by, maybe? Except, yeah, I guess that would be fine. P many sep P is opt. Is that what the thing is called in Haskell? Opt, like maybe parse something. parser. I mean, it looks like it exists in some of them. Well, let's look up sum, which is an alternative. Oh, no, which is an alternative here. One or more, but is there something that is like an A or not it? Like, I mean, I guess I can write it myself. Oh, not P, but sep. So parse a separator if it's there, or don't. But throw it away in either case. Still there. Oh, I haven't reloaded. Yeah, so that was what was wrong. And there's all these stupid zip lists. Oh well. Okay. And I haven't even done the transformation from row major to column major yet. But we've done all the hard work at this point, I think. So let's write part 1, input to int, part 1 of P. No, I actually have to break it apart, don't I? Problem F of ops and args and ops is sum. That's probably correct. Sum solve so solve is going to give me back a zip list of int, and sum will traverse that to solve to add them all up, because sum works on any foldable, so that's fine. So let's just say problem f of args prime ops, where args prime is sequence A args, I guess. Type checks. It's a big number. Could be right. Million, 6 trillion? That's suspicious. Let me double check what the problem is actually asking for. Because I feel like you aren't usually asked for numbers that don't fit in 32 bits in Advent of Code. The answers to all the individual problems. Add them together, though. All right. Let's guess that this seems like a plausible answer. It's right. Okay. Great. So, I don't know. Like I said, this is way more complicated than it needed to be because I was trying out some unfamiliar ideas. And I'm sure there was a cleaner way to do this row major to column major conversion here. But in the end, I did sort of accomplish all the stuff I said I wanted to do, right? The parser parses things in row major order. So input is providing them in row major order. Part 1 says, oh, let me look at the columns by doing this sequence A, turning a zip list of zip list into a different zip list of zip list. And if it had just been a list of lists, I could have called transpose and everything would have been simpler, I guess. But then zipping it with the operator list at the end wouldn't have been quite as cute, right? It wouldn't have. You couldn't have just used the applicative. And I have this solve function that works for problem f's of any applicative. You know, if you ever had like a function that if you ever had like a problem f of IO where like the zip lists weren't predefined, but you prompted the user for them somehow, problem f would still solve that problem, or solve would still solve that problem f. And, you know, that's all I really wanted. I didn't quite figure out how to get coerce working, which is a little annoying. That's my experience with coerce. It's always impossible to get it to work. So, like I said, it's not the prettiest solution, but it is what I wanted. So, I mean, how mad can I be? The funny thing is, like, I don't need that identity version at all, but it's there, like, as a proof of concept sort of thing. Yeah, this is all fine. Day 6, part 1. All right, let's see what's going on in part 2. The big cephalopods come back to check on how things are going. When they see that your grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read cephalopod math. Ha! Cephalopod math is written right to left in columns. What? Each number is given in its own column. Oh no! So this is not matching at all with the kind of flexibility that I built in. The most significant digit at the top and least significant digit at the bottom. Okay. So it seems like the alignment does matter here, right? Because look at this third column. They're saying this 8 is just a single number. Whereas if 64 and 98 have been shifted right, as they are in this example, then it would be 8, 4, 8. Oh. So I need a completely different parser because I threw away the alignment information. And this solve function that handles any f, well, we knew it wasn't going to be useful, right? The generality was not necessary, but it was interesting. So it's maybe not a surprise that indeed it is not useful. Okay, well, let's go look more closely at the input file, I guess. Okay, this is impossible to read. Let's look at the example. Okay. So it looks like the operator looks like it's in the leftmost column every time, but we actually saw that that wasn't the case in our example input, right? That was one of the reasons it didn't parse first. Oh no, it did. It was on the left. Oh, it was because it ended with some blanks. Okay. So the column the operator is in is the start column, I guess, of all the numbers. Oh man, I don't want to do this. Also, I suppose, I didn't handle that the rows might start with a space, did I? So really that should have gone here. Like that. And I guess what I would do is then say opt p is p or empty, and then I could say opt sep, and then not need so many parentheses. And this is now like my own custom sepvi that does not match with the traditional definition because it's not even sep end by, which is a traditional one, like where there can optionally be one at the end. There's also optionally one at the start, which is very non-traditional. But that's okay. I'm just using it for myself here. But it's not going to do anything for part 2. Although, I guess what I should do is commit that and make sure it still produces the same answer. That looks about the same. Yeah, it is. Okay. Okay, we'll just pretend I did that the first time around. So you can't really parse a row into a number. Well, hang on. What if I transposed the input file? What would that even look like? I would have 1 space plus, 2 4 space plus, 1 5 or 2 4 blank. Also, this is times, not plus. I can't believe these maniacs who said space 32 is the same number as like 32 space. I mean, I guess that's true in normal writing too. Oh well, I guess I can't be too mad. Yeah, though, if we transpose the input file, this all gets somewhat more readable, right? We read a row that has a number and ends with an operator. And then another row, perhaps, that has just a number and no operator. Some number of rows with no, or not, they won't, yeah, they'll be rows that have a number and no operator. And then finally, one or more rows with no numbers or operators. And then another row that ends with an operator. So the parsing problem is 15 kinds of impossible if you try to do it row major. But if you just transpose the whole input file before you even look at it, which of course means you have to hold it all in memory at once, which is, you know, if we had a very large input file, this wouldn't scale, but we don't. And it would sure be nice if this could still parse to a problem f of something. Zip list, I guess. Well, no. I mean, It'll actually kind of parse to just like a list of boring ass problems, won't it? Like identity almost? No, it can't be identity. Because we're going to have... Well, it could parse to a list of problem F of identities, but why not just a problem F of list in that case? Or, well, zip list, and then it would actually be normal and correct. So, okay, I guess we need to take this whole parser and put it inside of part 1 for starters. Well, why am I doing a let in when I could just add this to the where? So does this still run? No, because I haven't written parse, of course. But we can then say parse is just this. Except it'll all be indented wrong. Huh? Oh, prepare. I guess my input is just going to be a string, basically. Okay. And that's the same number. So let's get that committed. Hello? Oh, here we are. Day 6. Separate parser for part 1 and part 2. So again, we're going to take a sheet. But then I want a problem F of zip list again, right? Yeah, this whole zip list idea was silly, but it is what it is. Operands. I mean, maybe I should just parse an actual list of ordinary problem, right? Because when I transpose, that's sort of what I'm going to get. Each row no, it's not the case that each row of the transpose input file will be one problem. It'll be one of the operands in a problem in a way. Yeah, so producing a problem F is going to be kind of hard, actually, right? Because we won't have like a zip list of all the operands and then another zip list of all the operators. We're going to have a list of like chunks of, I don't know, 4 or 5 or whatever, however many rows are in our actual input. Where there's like a chunk of 4 things that are the operands. Okay, so I think actually I do actually just want a list of problem F of identity in a way. Some map solve problems in a way where problems is parse the sheet. Now, wait a minute. Sum isn't going to be quite right, because solve is going to give me back an identity of int, and I'll have a list of those. I'll have a list of identity of int, and sum won't like that. What's it called? Run identity? Get identity? Run identity, okay. There. So, actually we want to parse transpose of the sheet, which is from data list. Parse is this. Then input is many, well, it's some problem, I guess. A problem is a number, which is just a decimal. No, because it could be surrounded by spaces on either or both sides. It's a number, which I guess we've been calling arg. It's well, we're gonna have to call problem F at some point in here. And what's the type I'm building towards? It's an identity of zip list of operand and then an identity of operator. So I'm gonna need to Okay. It's mapping some function f. We'll figure that out in a minute. Over the result of a header column, I guess, and then some follower trailer. Okay, where my idea is that a header is an it returns two things, an arg and then also an op. Whereas a trailer is just an arg. So we parse a header, some number of args, and so this calls P, I guess, where P of arg1 op and args is problem f of zip list of arg1 args and op. Except I have to put an identity in there somewhere. Yeah. It's pretty stupid, doesn't it? We still have to define arg, and we can borrow op from up here. We can't borrow arg because it's just a decimal, whereas we actually want to handle the... Why won't you indent to where I want you to go? What's wrong with my... I see. There we go. And an arg is... Well, let's just say spaces is this. Oh, but it's actually many of them. Oh, this is probably not a good idea to refactor this then, because I probably need it to be some in there. Yeah, I do. Okay, fine. So it's a decimal surrounded by 0 or more spaces on each side. Okay, I mean, this surely can't compile, but like, how are we looking? How bad is it? It's hard to know, right? Oh, yeah, that's true. In order to transpose, I need a list of lists. The rows are the lines in the file, not just the characters in the file. Yeah, I guess the issue you're pointing out is that now that I've transposed the input file, I don't have a list of characters anymore. I have a list of lines. So I can unlines it again, I guess. Is that the right thing to do, or would it be better to have my regex somehow consume lines? I don't think I can do that very well. Because the regex engine works on any token stream. But I need it to be able... I need to treat... Yeah, okay, well... We'll do it like this, I guess. And now, like, it actually compiles, which is stunning. It's not right because I'm not having I don't handle the new lines yet. But I think it's really close. Because I just need this, right? I need a new line at the end of each. No. Okay, let me go back and look at what the input file looks again. So if I transpose this, I'd have bleh. So the header row needs a new line at the end. There's one here. And each other row needs one at the end as well. Okay. And then I also need to handle the blank line in between them. Okay. Where do I define spaces? It's in here. Okay. Let's lift it up to the top level, I guess. And it won't indent right because I'm not done with this, but... and then a problem also needs... okay, so an arg shouldn't assume it has a new line at the end, because it might be the one followed by the multiplication or addition symbol. So we need it here, where we call some arg, and also in header, where we call arg, and then end it with... Okay, so... some arg, each followed by a new line. And then also... no, because the last one won't have an extra row. Okay, so we need, like... this to be optional. Did I define opt somewhere? I thought I did. There it is. I guess I'm only using set by in this one, huh? Interesting. So I wanted opt at the end of a problem to optionally have an extra new line separating it from the next problem, I think. I can't imagine this will parse correctly. If it still compiles even. Yeah. I didn't define opt, and op. I think I'm fine shadowing that. This should really be at the top level. Somehow I only needed spaces in this one. Yeah, and you're annoyed about me shadowing stuff. Wait, I defined opt twice? No, it's complaining about op. It's complaining that opt has no type signature, which, I mean, that's fair enough. We can write these now. Opt takes an F and just returns another F. Op is... Oh, I actually have to name the regex type. RE char operator? Now I have to import RE to be able to mention that type. You gotta import alternative? It's not in Prelude still? Come on. Oh, F of A to F of A? Yes, that's true. Oh, do I just want empty? I guess so. I didn't want them empty. They happen to be the same for regexes, I guess. There, now we're just back at shadowing of op. Which, I mean, leave me alone, will ya? Where even is it? Here. Fine. Okay, let's just run part 2. Yeah, of course it doesn't parse, and it's completely impossible to debug the way I've written it. Okay. So that should be the simplest kind of problem we could write, shouldn't it? Add together 1 and 2. And of course it doesn't work. Who knows why? This is the kind of thing where I kind of miss closure because it's easier to peek into the workings of something because every bit of data is just like a list or, you know, built up of the atoms that are... They're fairly interchangeable. You don't have custom types for everything, and so you can just, like... And you can do I/O in the middle of a function, print out, hey, what is this thing? Or, you know? And in Haskell, it's so hard. It's easy to make things opaque. You know, I had this little question mark macro I would write, and I guess here's not a good place to example it, but, you know, there isn't even a good place to say, like, I could say, okay, you know, what are arg1 and args here? And there was this little macro that would print out the arg1 args, but then return the value. And that's basically just the same as like what debug trace does, I guess, but it's so much more of a hassle to do, and it's not, you don't get as nice printouts from it. And you have to change the code, not just wrap it in a single function call. Like, what can I even... What's... Since the parser doesn't work even on a small file, the thing to do is to try a smaller version of the parser and see if that part works, right? And then if it does, you try a different part and see which part doesn't work on the inputs you expect it to. But it's kind of impossible. I told you guys I didn't want to do this, by the way. It's an interesting problem. It's just a little imposing. Okay, well, let's start, I suppose, with this. Just make sure this is doing the thing I think it should be. You can't copy and paste between tmux windows in that way. You have to do it like tmux, not like emacs. 1 plus. Uh-oh. This isn't what I wanted, is it? There's too many new lines before the 2. Oh, that's true. They should actually be... This is a bad input example. They should look like this. Okay. Okay, so it still doesn't parse. But that's a more correct input. So I can like lift all of these out to the top level and try running them. Okay, and it's, you know, warning about shadowing and stuff, but that's all right. So like I'm pretty sure arg is right. Spaces and new line, like, they're correct. The issue has got to be in problem or header. Or, wait a minute. How is the division of labor between input and problem? Is that correct? No, something's not right there. we actually want is more like this. Where we just have opt spaces at the end of each problem. So we take a header row, and then at least one other argument, each followed by a new line. Okay, let me look at this again. What is this spaces all about? So we're going to have blue, that's one row, a header row. Then we'll have 2, 4, and optionally some spaces. And then a new line. So that's part of arg is the new line, yeah. And then this row here isn't really part of the problem, right? It should be part of the separator between problems. So it's like, I really should be using set by, not sum, I think. Does this still compile? Yes, okay. Where, remember, set by my version of set by here can optionally start or end with the separator. So I think I want problem set by spaces and a new line, right? Because there definitely should be one completely empty line in between each problem. This opt spaces here, is that wrong too? I think it is. Probably wouldn't do any harm, but a header and then a bunch of args followed by new lines. Yeah, that looks a little better. Yeah, still doesn't parse though, huh? Screw you. Oh, because I haven't changed part 2 at all. Oh no. Okay, so I need to take these and put them maybe back inside of part 2. Or I guess just make sure to use the outer ones. Still no parse. Very funny. So a problem, but it's problems separated by blank lines. Okay, so what if we say header I think this should be like space 1, 2, 3 times. Does it want a new line? Yes. There shouldn't be spaces after, right? The op is just followed by a blank line. It's the end of the line every time. Nothing. Well, but that's right. No. Because I actually do have to put the new line in. And then that parses. 1, 2, 3 times. Okay, so that's right. So what if I said match a problem? What should that look like? A header and at least one argument, right? One, 3 times, and then 5 new line. Let problem f a b equal this. No. Case this of f map problem f a b to a b on that. So it successfully parses 1, 2, 3, and 5 being multiplied this way. So this is good. Problem matches what I think it should match. So if the problem is not, haha, with the problem definition, it seems as though it must be in the input definition, or of course the problem falls apart on more complicated inputs somehow. Or maybe I'm transposing wrong. Wait. The problem... My testing where I was calling a minute ago part 2 of... No, wait, this looks right. This should be 1 plus 2. This is before the transposition, and that seems fine. Does it just want another new line there? No. Okay, so let's make sure we can handle multiple problems then. What would that look like? First of all, this one, yeah, this returns nothing, but I don't think it should. Because a single problem should be a valid input. So anything that problem matches input should also match. Because input is just a bunch of problems. Yeah, that's troubling. Or, I mean, it's good news in a way, because I found something that isn't behaving the way I wanted it to. So there must be something wrong with my set by? Maybe? All input is doing is saying problem separated by spaces in a new line, and sep by says maybe match a sep, which would be spaces. Then match a p and cons it onto many this parenthesis is in the wrong place. Many sep p's, and then I kind of feel like I want this at the end. Op sep, then do all the real parsing of p's and seps and stuff. And then another op sep. Still wrong. Let me just confirm. Yeah, this is the exact same text matches a problem, but doesn't match an input. But it does, right? Is something wrong with opt? P or empty? I think opt is okay. If you can match the sep, it's fine to do so. I think, because spaces new line. I mean, spaces is just many spaces, and then we have a new line. So if there's a whole blank line, it should be okay to consume that, right? Yeah, I don't understand what I'm missing on this. Anything that matches a problem should also match sep by pretty much anything, right? So let's for a moment here change sep by, or change problem. And now this should parse, right? Yeah, because it's literally just doing nothing different from... but hang on. I wanted to test the input one. Yeah, so it parses the same and it produces a list. So somehow consuming... But all of my uses in sep_by of sep are optional, no? No. I see. This one is non-optional. But it's inside of many. So this many should resolve to, oh, there are 0. Like, there's one mandatory P, and then 0 or more instances of a separator followed by P. And this should produce 0. Now, if we were using a parser that consumed input and refused to give it back, this would be wrong, because we would consume the sep and then discover there's no P, and then be unable to give sep back later. But with text regex applicative, it explores all branches simultaneously. And so this many matching 0 things, even though it could consume a prefix of the input, that's not a thing that matters in text regex applicative. So this should conclude, there are 0 instances of sep followed by P. Maybe the issue is that, I don't know, how could there be an issue? If this matches once... Okay, first of all, does opt_sep match at the beginning of our input? Spaces followed by new line? No. There's spaces before the 1, 2, 3, but then not a new line. So that'll fail to match. So then we go in here and we try to match P, which is a problem, which we've already said matches the entire input string. And then we'll try to match many separators followed by P, which should fail because we've consumed the whole input. And then we'll try to optionally match... Well, it won't fail. It'll succeed 0 times. Then we'll optionally consume another separator, which will not consume anything, because we're at the end of the input. So if problem matches, then input should match, but it doesn't. And this whole question of like transposing, we're leaving aside for the moment because I'm passing in an input that's already been transposed is the idea. Yeah, something's wrong with my understanding of text regex applicative, maybe? Or how alternative works? Like, am I wrong about many? Many is 0 or more, isn't it? I guess if it were 1 or more, I'd have some problems. Many in control applicative. 0 or more. Yeah. Okay. That's what I thought. I mean, I could pull out this bit about starting and ending optionally with sep, I guess. I used it here. I don't really remember why anymore. But I could give these two their own sep bys. I remember there's some kind of issue with alternatives or parsers or something where if you give the many function a parser that could consume 0 input, you're in for trouble. It could succeed while consuming 0 input because it can't really decide how many of them there should be. But I don't have any of those. All right, I'm going to go away for a while and poke at this and come back. All right, I'm back. I've been away for some time. I didn't spend all the time thinking about this program. Most of the time, in fact, I did not. But finally, I revisited this, and it came into my head what the problem was. And you can't see it now because I fixed it. But it was my implementation of optional, which I called opt, that was wrong. It should be in here somewhere, shouldn't it? Well, alright, whatever. I guess not. Yeah, put that back, please. Okay. But, okay, so set by... I realized... my definition of optional, when I was using it as an internal thing in part 1 somewhere. Oh, because setby used it. And when it was internal, it inferred that the type was like a list of characters or something. And I had it, be, it was like, optional of P is either P or empty. Mempty, I said, the empty monoid thing. And when I extracted at the top level, it said, oh, you can't use mempty because you only have an alternative constraint, not a monoid constraint. And I was like, okay, that's fine. I only need the alternative one anyway. I'll use empty because that's in alternative. And I didn't think at all about that. But that's what was wrong. Because empty for... where do I have... empty for a parser isn't a parser that always succeeds matching nothing. It's a parser that always fails. And mempty is a parser which always succeeds returning nothing, which is the same thing as, or well, returning the empty whatever. Here, matches the empty string, and its return value is the mempty value of type A. So mempty would have been correct, except that I was trying to do something that didn't have a monoid constraint. And so, okay, that was... I'm only using optional to return things whose value I don't care about, and so really I can just return unit instead of A in optional. And I realized also that I was sure this existed somewhere, but I thought it was called opt. It turns out it's called optional. That's why I didn't find it. But once I had the type signature for the thing I wanted, I searched for that and I found optional, which, where is it? I had it a second ago. Yeah. If you have an FA and you want an F of maybe A, that's kind of the sensible type for this to have. And this is, it's just F mapped into V or pure nothing. So either the parser itself or a parser that always succeeds and returns nothing. So this is what I actually wanted for my optional parser. And the fact that that's wrong is why setby was wrong. I was spending much time debugging setby, but the problem was actually an optional. These parentheses I think I fixed on camera, but then I unfixed them in my little undo string there. But yeah, this is fine. I think I got to put the type signature back because I erased it while I was trying to get undo to rescue the old definition of optional. It takes alternative F, an FA, and an FB, and returns an F of list of A. Is that right? Yeah. And so now, like, we can match input to a single thing. And we could even test then what it looks, can it match multiple things? You know, if I say, I haven't tried this much. Yeah, this parses 2. Cool. So let's put these back in here now. And now this works. It says, oh, add together 1 and 2, no problem. And, you know, I don't really remember anymore how to produce these problems. So it's assuming they've already been transposed. Okay, right. Oh no, but part 2 doesn't assume that. Well, the testing I was doing earlier did. So constructing inputs to part 2 is much more complicated to do by hand. All right, well, it's a number. Maybe it's even right. It parsed the input file correctly and produced a number. I'm very excited about that. How does this compare with the number we had for part 1, out of curiosity? This is 3, 6, 9, 14 digits, whereas this is 3, 6, 9, 3, 6. Similar number of digits. Off by like 1. That's the right answer. Okay, so I spent a lot of time tracking down a bug that was related basically to my reimplementation of my incorrect reimplementation of a very simple standard library function, just because I didn't want to go find it. So that's a lesson, I guess, to learn, is don't do that. And I mean, the parser today is complicated, but it's not as horrible as it looked like it would be when reading the problem definition for either part 1 or part 2, really. Most of the difficulty in this problem was self-inflicted in the way I decided to represent a problem with this problem F thing, so that I could handle a problem of identity. Oh, I forgot, I actually have... a problem here. I said I wasn't going to use this, where you have an identity. It turns out I actually did use it down here, but I never actually used the type name. It's an alias for problem F with identity, and then I pass it here. Oh well. So anyway, most of the complexity was this, and figuring out how to handle it. And I think it's cool. It's not the best way to solve this problem. I've said that many times, I just want to repeat it again. But it's a very flexible kind of storage container that can handle many different ways of embedding problems in interesting spaces that still, because of the applicative machinery, permit a single solve function that polymorphically handles any of them, which is pretty cool. And we did end up using it, valued both at identity and at zip list, to handle the transposed and non-transposed input file, sort of. So, you know, it would have been simpler to just write 2 functions, or to have one function that takes a list of lists and call transpose on one of them before you go in. But this was still cool. Let's get this committed and done with. Today we definitely need to get add-p. There's probably some stuff I didn't need to... Oh, do I ever even use RE? I do. Is this needed? I guess so, because we are actually specific to regular expressions here. Okay. Part 1 got a small change because opt got removed and replaced with the standard library version, and set by got lifted up to the top level. And op also got lifted. Then we wrote part 2. All right. Day 6, part 2. Kind of a messy day, but some fun lessons, I guess. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.